Morning guys, welcome back to the One Auto channel. A little review for us today. The guys at Hubitools have sent me their Auto Tester, which is this little machine just here. It's the HU31025. Just to check it out, give them a quick review, give them some feedback. So I've been playing with it for the last couple of days. To be honest, I'm quite impressed with it. What it is, it's like a multimeter, like a DVOM. It does from 0 to 50 volts. So you can do your 6-volt motorbikes, 12-volt cars, 24-volt trucks, etc. What I'm going to do in this video, I'm just going to run you through some of its features and what it can do for you, and then what I'll do is I'll leave some links in the description to their Facebook page and to their website. If you're interested in it, go see them, they'll tell you the prices, tell them where you are, they'll tell you whereabouts their nearest dealer is. So let's crack on. Okay, let's just go over what we get inside this kit. Obviously you've got the actual tester itself, which is quite ergonomic, feels good, it's of good quality. So obviously you get that. You get some leads, you get a couple of crocodile clips, you get then your test leads that plug into the top of the tester. Now what I like about these, obviously they plug straight into there, but what I like about these is they've got these protective ends just here. So if you're going and testing in confined areas, and you're going in with two of them, say you're not going to touch them, they're very sharp as well, extremely sharp, so mind your fingers on those. Also, if you don't want that and you want to go in a little bit deeper, the cap comes off, like so. And then again, and even further, you can unplug that and plug that into other test leads as well. So that's what I really like about these. Also, in the kit here, we've got some leads for when we're checking our amp drawer. I'll show you those a bit later on. They plug into the top and they've got an inline fuse as well. There's a 1 amp and there's a 30 amp just there. And obviously your set of instructions, which in the instructions that I got, all well and good. It's all pictures. It's easy enough to follow. There is one little printing error though. However, it does say though it takes 3 AAA batteries. It doesn't. It takes 3 AA batteries. Never mind. We got there in the end. So let's run through what we can do with this thing. Okay, so the operation of this little machine is quite simple. It's just a case of press and hold to turn the thing on, and then it will just go through. So this first setting here is continuity, and then you turn it again there, and you've got your ampage, and so ampage across the fuse, and your amp draw, and then we've got your volts DC, and then your voltage drop on your starter motor voltage drop. And then you've got your ohms, checking your resistance, and then finally you've got your frequency and your duty cycle settings. So I'll run through those in a minute. First one, continuity, quite simple. It's just checking the continuity, for instance, of a wire. So as I touch those together, we get a little blue light come on and an audible bleep. So for instance, usages for checking continuity. Let's say we've got a bit of wiring loom. This one's off of a injector, a little piece of injector wiring loom, and we just want, say for instance, to identify what wire goes to what pin. Quite simply, you'll get your one end of your test lead, just touch it there on a pin, and then on your wires at the other end where you want to be checking, we can just run through each one individually and see which one it is. That one there we are. So we know that that wire there isn't broken, is one thing, and that on that pin it comes to this red and white wire just there. Again, let's just do a random one here. Let's take that wire. I can't even see the colour of it, so I'll just run through, touching each wire on the end. None of those, must be that one hiding down the back. There we go, yes it is. So quite a simple test there for the continuity. So while I'm here, before I turn the ignition on and start draining the battery, we'll just change it to the voltage setting. And we've got volts DC and we've got voltage drop for the starter motor. So you just use the right button to move it over, left button. You just toggle between the two there. So we want volts DC, and we just press the enter button, which is the power button, and we get volts DC. This now is just a standard voltmeter. So if we just want to check our battery, red to positive, black to negative, 12.88, and it's gone green, if you can see that. Basically this has a traffic light system, so green is good, yellow is okay, and red is bad. So it's all preset, you don't even have to think about it. You can just touch that there, it's gone green, happy days. 12.88 is ideals for now. So you could be inside the vehicle, you want to check power on a particular wire, you would just ground your black lead and then touch it, say, on a terminal or a connector and just check your power, like so. Pretty straightforward, like just a standard voltmeter, to be fair. So our other setting that we've got, we can just back out of there. If we've got voltage dropped, starter motor voltage drop, so we would just toggle that over and press enter, and it's saying start the vehicle and it will give you a voltage reading, but it's on 0 at the minute because we're not connected to anything. So we just pull those ends off here, we connect the crocodile clips that come with the set, and we go red to red, black to ground. So it's 0 at the minute, we just need to come back out of it and go back in. There we go, 12.8 and it's saying start the vehicle. So I'll go and do that now while you watch the screen. There we are, on 12.6 volt at the minute. So we'll start it up. So it's gone green, it's telling us it's okay, and showing us that it dropped to 10.6 while that starter motor was cranking, so that's all good. So our other setting, disconnected those leads from the battery, our other settings I want to show you is the ampage setting. Now you've got two options here. You've got ampage, and it's showing you, checking your ampage across the fuse. So your current flowing through your fuse is this one here, and then press the button over there, and then you've got ampage draw. We'll just start with this one first because it's most straightforward. And what I'll demonstrate here is just showing you what current is being pulled by one of my headlight fuses. So we'll go into it and we'll just press the enter button just here, and then we can select whether it's a mini fuse, your standard ATC fuse, or a maxi fuse. Well, in this case it's just your standard ATC, and you enter, and then you've got your options here of what rating the fuse is. So mine's a 15 amp, and we'll enter that. So now it's saying, now it's got it there that it's an ATC fuse that we're testing, and it's a 15 amp fuse. So I'll turn my headlights on and then we'll test it. And I'll go across the headlight fuse. And it's showing us there 3.56 amps. So what it does is it bleeps a couple of times and it locks it in that position. So to zero it, just touch your leads together. It'll say 0 and bleep at you. And just do that again. So touch that on your fuse, 3.56. It bleeps once to say it's got it, and then it'll bleep a few more times. That's going to tell you it's locked, so it's locked that figure in there now. So you could be probing it just here and be turning something on in the car, but when you come here it's locked at that particular ampage. Okay, so if I want to test some others, I'll just turn the knob off of ampage, then back again, select my amp, and select my standard fuse. And these ones I'm going to be testing here are 10 amp, so we'll enter that. And then I'll touch the 10 across each side of the fuse on the 10 amps, and there shouldn't be anything coming through these ones. So it bleeps to tell me that it's got a connection, that the 0 current, 0 amps being run through that fuse. Like that. So that's really, really handy, that one. So another test we can do to check current flowing through a fuse, for instance, is on our fuel pump here, which is a 15 amp fuse in the fuse box. So I've set it to the standard fuse and to 15 amps, so I'll just start the engine now. Right. So we're reading at the moment 4.3 amps. That's better, we can hear ourselves now. So yeah, 4.3, 4.28 that it's locked out just there. You're looking at an average. You've got the current going through a motor, you'll see a ripple effect on a picoscope. So the ripple effect is taking the actual average through the centre of that ripple. So if I put a picture just there, that's what I took on the picoscope, and you can see the ripple on that. And that 4.2 to 5 is about average through the middle of that waveform there. So always remember that, but you can see at least there's current flow, so something's working. So the other current measuring feature on this is quite good as well, the amp draw. So bring that over to amp draw and press enter. Then you've got a choice there between 0 to 999 milliamps, basically 1 amp, or 1 to 30 amps. So in this instance I'm just going to say 1 to 30 amps. And you've got different leads to plug in, different test leads. So you've got the blue one here, which is for your 30 amp, and they're a fused link, and you've got this one here, which is your 1 amp. So I'm just going to connect this 30 amp one. You just put it so that the fuse side is on the plus side. You plug that in there. So this one's going to be measuring ampage draw. So what I'm going to do now is check, say, a parasitic draw on this battery. So if this battery's got a drain, say overnight, and we want to find out how much it's draining, we can do it like this. So disconnect your negative cable here, like so. Pop that, connect it back up, stick that down there. And we get our test leads and plug into the adapter cable, the red onto the fused wire, black on the other one. So now I want to connect between this negative. I want to see what's flowing through here, through this battery. So the scenario is the car's switched off, for instance. The car's switched off. Come out in the morning, the battery's dead. So crocodile clips on, put your positive onto your lead and your negative onto your negative post. That's going to reconnect the battery, so you'll probably hear some modules or some central locking fire into action, like just there. So you get your surge. First of all, it went up to about 5.99 amps, I believe. As all the central locking and all the computers woke up. Now, this is getting on a bit, this car. Some of the newer cars, all the modules are firing to life and they'll stay awake for quite a few minutes, hours even sometimes. So at the minute I'm quite happy with that. I've got no current draw at all. I mean, I haven't got a problem with this car, but I've got no current draw at all. We've got 0 amps there. So, situation is we've come out in the morning, the battery's flat. Why is the battery flat? Well, easiest one, most common one, you've got a light on in the car or outside the car even. Most favourite one probably is inside your boot, where you've got a light in there and it's stuck on and you can't even see it. So I'll open the door so my interior light will come on. You'll see now. There we go. We've got one interior light glowing inside, and that's pulling 0.84 of an amp. I mean, if that was on overnight, you're more than likely going to run your battery flat, so it won't be able to start in the morning. So if I close the door, it's on a timer, so when that light goes out, you'll see this will drop down. There we go, dimming out. So you can tell just opening up that door and letting it dim down, it hasn't dropped completely back down to 0, down to 0.1 amp there, so it's woke up a particular module. So let's deadlock my central lock in, and then we'll unlock it, and we shoot it there 2.4 amps. So you can see that something's happening there. I don't think it's the fastest in the world, and it doesn't actually lock, which would be a good feature, but however, that's okay. So that's the draw from the interior light we're seeing at present. So I've just rigged up another test here just to check the current draw on this main beam bulb in this headlight. So this is the setup for the experiment. I've just unplugged the back of the headlight bulb, which is that connector just there, and I'm just resting the terminal, just resting the lead into the connector, as you can see just here, and then the other lead's going onto the back of the bulb. So we're making the circuit through the actual meter itself. Okay, so I'll switch the main beam on now. Ignition, headlight, main beam. And there you go, you've got 4.3 amps that bulb is pulling, which is super. Then we move on to our resistance check, our ohms meter. So we turn that round to ohms, and it's as easy as that. We're checking the resistance in the wire. So if we touch them together, we're going to check the resistance in our leads, which is 0 ohms. That's what we want it to be. So let's go back to this bit of wiring loom again. Let's say we want to check one of the resistance of one of these wires. Let's just run through it. We can put it back onto continuity. Let's just have one of these red and white wires on this first connector because it's nearest to it. We touch the red and white wires. That's the one. It's that one just there. So we just flick that straight back then to our ohms meter. So we're onto that wire that we just identified, and we just touch that on the terminal just there, and we got 0 ohms. So that's a good wire. There's no resistance in that wire. Good. So set that over there. We've also, if you want to check components, the resistance of certain components, we've got here an old fuel rail of an old BMW, which was a known good runner because this was removed and the original one of the car fitted when we changed the motor over. So that's nice and easy to get to. So we can just check here, check across the fuel injector, put one on there and one on there, and we've got 10.89. At 10.9 ohms, so I can just run through and check all of these. So we've got 10.4, 10.73 and 10.9 again. Great stuff. So for our last test, got the knob turned over here to hertz, so that's going to give us our duty cycle basically. So for instance, if I move it over there and enter, this is going to give us our duty cycle in a percentage, and if we go back, this is going to give us our duty cycle as a frequency and tell us what voltage we're currently running at. So I'm connected on this one to my idle speed control valve. I don't know if we can see down there, but I've just back probed the connector. I've got 2 back probes in there coming up on these 2 jumper wires, and I'm just connected there. Okay, so we'll start the engine. It's a cold engine, so the idle will be high. We've got plenty of charge in the battery. I've had the headlights on during the testing and everything for this. So there we go, charging there 15 volts, and we're at 1.09 kilohertz. So what I need to do now, I'll just back out of here and go to the duty cycle percentage. There we go. Currently we have a duty cycle on the idle air control valve 61 to 3%. So that's awesome. What you've got basically on your duty cycle, obviously you've got an on and off modulated signal coming from the PCM. So as the engine warms up, you see, it's going to change the duty cycle for us. There we are, so as the engine's warming up, it's needing less and less air bypass through that idle speed control valve. And duty cycle's going up there 70% now, look. Go back to the frequency. That's the frequency now, 1.25 kilohertz. Cracking, happy days. There we go then guys, quick overview there of the Hubitools Auto Tester, the HU31025. I'm quite impressed with it so far. What I'm going to be doing is I'm going to be using it in over the next few weeks, hopefully in some new diagnostic videos as well. Yeah, no, great, I'm quite impressed with it. Thanks for those guys for sending it over to me. I'm sure I can make use of that. So like I say, it's a nice hard case. Throw that in your toolbox, it's not going to get damaged. What I'm going to do is I'll put some links in the description to their Facebook page, to their website, and they've also got a YouTube channel with some other videos that they've made there of their tool. So I'll link that all in the description down there. So I'd just like to say thanks for watching, and don't forget, connect to me, Facebook, Twitter, Google+. See you next time.